All right, so let's recap. We've talked about translations, and translations are what we were calling just a slide in yesterday's lesson. So we just can slide along the plane and map one point or segment or shape to another. So a translation occurs along a given vector. And so a vector is a segment in the plane. Here's a vector. One of its endpoints is the start and the other is the end. And everything's going to move in the direction from the starting point to the ending point. And the length of the vector is important because that's the distance that every point in the original is going to move to its image. So here are two vectors, AB and BA, and we talked about that earlier. So a translation of a plane along a given vector is a basic rigid motion. And remember we said a rigid motion is one that preserves distances. So when we did those translations that we did, like these, like this one, the distance between Q and P is the same as the distance between Q prime and P prime under the same translation. So the distances are preserved. And so here's the three basic properties of translation. Maps a line to a line, we saw that, array to array, a segment to a segment, and angle to angle. Shapes don't change, nothing changes. A translation preserves lengths of segments and degrees of angles. So those are the three basic properties of translations that we saw. And it makes sense because it's just simply a slide along the plane. Okay, so what you should do now is do your exit ticket and be sure to have your exit ticket checked before you go on to the problem set because the exit ticket is going to check you on sort of a lot of the terminology, naming vectors, choosing, like in number 2, you're going to choose which vector would map the point A to its image T of A, okay? And same thing down here, you're going to try to come up with the vector that would map this line AB or the segment AB onto the segment CD, and so on. So check yourself on your exit ticket and then move on to the problem set, and I will see you all on Monday. I don't know about you, but I'm having fun with this, and I think we're going to enjoy this unit.